Hello and welcome to a introduction of area tiles and how they will be useful us in algebra. So area tiles are very good for us because they help us with the visual representation of a algebraic expression and how it interacts with one another. So an area, as stated below, is the product of a rectangle's dimensions, and more importantly, the dimensions are just the length and the width of a rectangle. So just looking at a rectangle will, for us, it will be the height or how long it is, and the width will be how wide it is. And just to recall, the area of a rectangle, as it states above, is equal to its length times its width. So let's go into what the area tiles actually are. So let's see how to read an area tile. Well, an area tile comes in the form of a single unit, a bar, or a square unit. So first things first, we need to figure out the areas of these pieces. So the area of the small purple square would be 1 by 1, which means that the area is 1 times 1, meaning that the area of the purple square is 1. The area of the blue bar would be 1 times x, which is its length times its width, which means that it's just x. And then the area of the final square, which is x by x, we just multiply x times x, and we get x squared. So these are the three areas that we'll be dealing with. And this will help us with some algebraic expressions. For example, how do we multiply something in the form of x plus 2 times x plus 1? Well, what we can do is call this the length and this the width. Because remember, the area of a rectangle is just the length times its width. And since we have x plus 2 times x plus 1, we could very easily represent this as an area of dimensions x plus 2 by x plus 1. So first things first, let's see how to make a dimension for the length of x plus 2. So what we would want to do is make sure that we have a length of x a length of x and then 2 extra units. So altogether it will be a length of x plus 1 plus 1, which altogether is x plus 2. So that is our length. Now for our width, we will do something very similar. So we need to make sure that we have a distance of x long and then 1 extra unit, so that we have x plus 1, meaning that this width is x plus 1 unit long. Now what we're going to do is see how their areas will interact with one another. So for this first product, I have x by x, which is very similar to our green square from before. So I'm going to take a green square and place it where x times x is. As you can see, x comes down and x comes across. So that means this will need an area of x times x, or in other words, x squared. Going down, x is now going to need to multiply by 1. So the area that has a length of 1 and a width of x would be this blue bar. 1 times x is just x, so we're going to use the blue bar. Again, x times 1 is still the blue bar x. So let's reorientate it, just like so. And finally, we must do it for the other column too. So let's take 1 times x. Well, that's still 1 times x is the blue bar. And then we must find 1 times 1, which will be the purple square. And again, 1 times 1, which will be, again, the purple square. Now we have everything organized. We have a rectangle that has dimensions x plus 1 by x plus 2. Now all we need to do now is just add the number of each area. So for this green area, we might have to recall that it has an area of x squared. Each of the blue areas, or the blue bars, have areas of x, and the purple squares have areas of 1. So let's just count. How many x squareds do we have? Well, we have 1x squared, and that's it. And then we need to add in however many x's we have, and we could see that we have 3 x's. And now we just need to add how many unit squares we have, which is just 2. So that means the product of x plus 2 times x plus 1 is equal to the expression on the right side, which is x squared plus 3x plus 2. Now, let's see you try one. How would you multiply x plus 3 times x plus 2? First, we need to recall that we're dealing with an area, so we're going to call this our length. We'll call this our width. And remember, we need the length to have x plus 3, so we're going to just say that this is going to be a length of x, and then plus 3 extra units. And of course, for the width, we have a length of x plus 2 extra units. So now, let me just label these. This is x plus 1 plus 1 plus 1, which all together creates x plus 3. And then on top we have x plus 1 plus 1, which means we have a width of x plus 2. So just as we've done before, we're going to go down and see what we have to multiply by. So first things first, we see that we have x times x, which will be an area of the green square x squared. Next we have x times 1, which means we have an area of 1 times x, which is just a single bar of x. Again, we have x by 1, so we'll need another blue bar. And finally, another 1 times x, so we need one last blue bar. And now moving on to the next column, we have 1 times x, which again is a blue bar of area x. And then we have another width of 1 by x, which means we have our final blue bar right here for x. And now we have many 1 by 1s, so we'll fill in the rest with 1 by 1s. So we have 1 times 1, which is x, or sorry, 1. We have 1 by 1, which is 1. We have one more 1 by 1, which is 1. 1 by 1, which is 1. 1 by 1, which is still 1. Finally, 1 by 1, which will be 1. Now we just need to count how many of each area we have, so we could see that we have 1x squared, then we're going to add 6x's, and then we're going to add, 5x's, which are the blue bars, and then we have 6 1s, which are the purple squares, and that is equal to x plus 2 by x plus 3. Okay, finally, I would like to ask you, how do you think we could extend our area tiles to multiply something of the form x minus 2 and x plus 3? First things first, what are some things that you notice that are different from what we've multiplied by? And do you think it will make a difference? Please save your answers and keep it for the next time we meet, and I would like to hear from each of you, and if you have questions, please let me know. I will see you all next time.